Example I want you to do for extra credit. I'm going to walk you through step by step and tell you all the little neat tricks that you can play with this problem. And we're going to start off with finding the equation of a circle that goes through these 3 points. I'm going to label this point A, we'll call this one point B, and call this one point C. It's really important to know which ones you're talking about so you can discuss them cleanly in this problem because it's going to get a little messy. So the first thing that it would probably be good is, number one, you do not want to pick 3 points that are collinear. You don't want to pick the points so that they're vertical because then it's not going to have a slope. And you don't want to pick points that are horizontal because the slope is 0, and if we find the perpendicular to that, it would become undefined. So we want to avoid those 3 possibilities. So just pick any 3 points, and the way I pick them is I use the x-coordinates as even and the y-coordinates as odd. And what that does is when we start finding midpoints, it makes the answers come out as whole numbers rather than as fractions. So you can use that pattern if you want, but they can't be, obviously, the 3 points that I have chosen. So I'm going to go through this step by step and see how it works. So step number 1, we're going to construct 2 of the line segments. It doesn't matter which ones you pair up. In this case, I paired up A and B for line segment AB and BC for line segment BC. And step 1 technically is, out of these 2 segments, we want to find the midpoints. So to find the midpoints of AB and BC, we're going to use the midpoint formula. So I'm going to call it midpoint AB. Will be the first one I'm looking for. So when we're finding the midpoint of AB, we're going to concentrate on just the first 2 coordinates. And if you remember the formula, it is just the sum of the x's divided by 2 and the sum of the y's divided by 2. So the midpoint of AB is going to be -1, comma 2. So that would be right here. That would be the midpoint of AB. Okay. Now if we want to find the midpoint of BC, do the exact same thing. Just use the last 2 coordinates. So we're going to go 0 plus 4 and take that answer and divide by 2. And the next one would be -1 plus 3. And we're going to take that and divide it by 2. So the midpoint of BC is going to be 2, comma 1, which would be right here. And this is just starting to do that construction of the perpendicular bisectors that I want to intersect to give me my center point. So these would be the midpoints that we're going to write for the equations of the lines. The lines are going to go right through these 2 points. So let's make them kind of special, and I'll bring them back to life later on. So here's one of them, and here's the other. We'll use these later. Anything in a red box we're going to use later. All right, so besides that, we need to do another little step. Step 2, we're going to find the slopes of these line segments. So we're going to find the slope of AB, and then we're going to find the slope of line segment BC. And if you remember right, slope is usually little m, so I'll just call it little m AB. Remember, slope is change in y over change in x. The biggest problem with this problem is people getting it upside down. So when you do change in y's between A and B, you're going to be doing 5 minus a -1 for the change in y, and then for the change in x, it's going to be -2 minus 0. So the top is going to be +6, the bottom is going to be -2, and our answer is -3. So the slope of line segment AB has a slope of down 3 over 1. Okay. And then we're going to do the slope of the other line segment, BC. Again, we're going to do change in y over change in x. And the change in y is going to be, well, here's C. So it would be -1 minus 3 over 0 minus 4, which will give us -4 divided by -4, better known as positive 1. Now these are the slopes of these line segments, but what I'm looking for is the perpendicular bisectors of each of these line segments so that they can run into each other. So what I really want out of this is the perpendicular of AB. So I'm going to look for the slope of AB's perpendicular. Now if you remember back from a chapter there, we're going to be looking at this negative 3, and to find its perpendicular slope, it's the negative reciprocal, which would be 1/3. And the perpendicular to BC, I'll write it this way, is going to be the negative reciprocal of BC's slope. Well, negative reciprocal of 1 is negative 1. And we'll be using these two pieces later on also. So the perpendicular slope for the first segment, 1/3, so it'll be going that way. And the perpendicular slope for the second line is going to be negative 1, and it would be going that way. All right, and we'll use those later as we move through this. All right, step number 3, we're going to find the equations of these perpendicular bisectors. So we need to kind of go back and pick some to give us one equation of one of these lines. Specifically, we're going to be looking at this line right here. So the point that I gave you here is -2 or -1, 2, and the slope of this line is 1/3. Now to find the equation of the line, we're going to go y minus y sub 1, back up, do it in blue, y minus y sub 1 is equal to mx minus x sub 1. Alright, so we have y minus, now y sub 1 is going to be the y coordinate up here, so y minus 2 is equal to 1/3 is the slope we're looking at, x minus a negative 1. And if we solve for y, we're going to get y minus 2 is equal to 1/3 of x plus 1/3, and then add 2 to both sides. So we're going to get y equals 1/3 of x plus 6/3, so this would be plus 7/3. Now this is the line for the perpendicular bisector of AB. Okay. Duplicate and delete a few things. Alright, and we do the same thing. We're going to go y minus y sub 1, which is 1 in this case, is equal to the perpendicular slope of -1, x minus the x coordinate, which is 2 from our midpoint. And we can solve this one also for y. So we're going to get y minus 1 equals negative x plus 2, and add 1 to both sides, and we'll get negative x plus 3. So this one is the equation for this line here. It's going through the point 2, 1, and it's perpendicular to my line segment BC. Okay. Now, with these two equations, we're going to come up with their intersection. So we're going to be looking for what is this point right here. And that's really important because any point on a perpendicular bisector is equidistant from the endpoints of that line segment. And it happens to be on both perpendicular bisectors, so it's equidistant from all 3 points. Therefore, this point will be called the center. All right, to find this, we're going to take our two equations, y equals 1/3 x plus 7/3, which is this line, and y equals 3 minus x, which is this line. And we're trying to find their intersection, which is right here. And one way of doing that is recognizing that both of these equations are equal to y, so we can find out when they equal each other, and I know they equal each other because they do share this common point. So we're going to solve the equation 1/3 x plus 7/3 and set it equal to the other one, which is 3 minus x, and solve for x. So probably the first thing I'd do is get rid of all the fractions, multiply everything by 3, so you're going to get x plus 7 is equal to 9 minus 3x, and then solve for x. So add 3x across, subtract 7, and then finally divide both sides by 4, and we get x equals a half. So the x-coordinate of the midpoint, or the x-coordinate of the center of the circle is a half. And to find the y-coordinate, I would plug it into the easier of the two equations and solve that one for y. So we're going to get y equals 3 minus x. I know that x is equal to a half, so I'm going to have y equals 3 minus a half. And this is the same thing as 6 halves minus 1 half, which would give us y equals 5 halves. So the center of the circle is going to be 1 half 5 halves, which is a half this way on the x-axis and 2.5 that way on the y-axis. So this point right here is going to be my center. My 1 half 5 halves is going to literally be the center of my circle. Alright, so now that I have the center point at a half 5 halves, I want to find the radius of this circle. That would be my step 5. Find the distance between this point and any point on the circle. Now these 3 points here are the original 3 points, negative 2, 5, 0, negative 1, and 4, 3. Don't go back to the midpoints. So this coordinate over here that I chose, you could have choose any of them. It doesn't matter. I chose to use 4, 3. Way over here. So I'm using this last point. But it can be any one of the 3 originals. And to find the radius, it's literally just the distance between this point at the center and this point at the edge of the circle. So I'm going to use the distance formula. So the distance formula says it's equal to the square root of the change in x squared plus the change in y squared. Alright, so distance is equal to the square root of, this is where it gets a little messy, but don't worry about it. The changes in x would be 4 minus a half squared plus 3 minus 5 halves squared. So let's see here. This would be d equals the square root of 49 fourths plus, and then 3 minus 5 halves, square it, and that's a fourth. And 49 fourths plus 1 fourth is better known as 50 fourths. And this reduces rather nicely into 25 halves, or 5 over the square root of 2. A lot of different ways of writing it, but this is going to be the radius of our circle. And for the formula of our circle, all we need is r squared. And r squared in this case is literally just 25 halves. Okay, so now we have everything for the equation of a circle. We have what r squared is equal to, which is here. And we have the center, which was 1 half, comma, 5 halves. And putting these two pieces of information is together is the last step. The equation of a circle is that nice simple formula. X minus h all squared plus y minus k all squared is equal to r squared. And plug in what we know. Now h in this case is a half, so it would be x minus a half all squared plus y minus 5 halves all squared is equal to our radius squared, which we found to be 25 halves. And that would be the end of the problem. This is all we wanted. That's the equation of the circle that goes through the 3 given points. Negative 2, 5, 0, negative 1, and 4, 3, and they're all on the circle perfectly. Okay, that's it. So for extra credit, if you can come up with the equation of a circle starting with any 3 points that are non-collinear, non-vertical, non-horizontal, you get 10 points in the next test. Good luck.